Hello everyone, my name is Misha Masyali and I am the freshman student in Bachelor of Science of Information Technologies, Media University. And today we're going to talk about the natural exponential functions, which are expressed as f of x is equal to e to the power of x. Actually, natural exponential functions are exponential functions with base e. E is a rational number and is named after the 18th century mathematician Leonhard Euler, which was a Swiss mathematician. In math, e is one of the most important numbers, considered as one of the most important 5 numbers, and is infinite. We can express it as 2.71, 82, 81, 82, 84, 3 dots, but simply we express it as 2.87. Yine 87. Simply we express it as 2.72. So let's talk about the inverse version of f of x is equal to e to the power of x. And the inverse version of this function will be a logarithmic function. As you can see from there, logarithm of x to the base e. And we know from logarithmic rules that this function is equal to ln x. And you can see the graph of this function. As you can see, when x gets 1, y gets 0, and except for that point, y will never get 0. As you can see from this part, this line will approach the y-axis, but it will never touch it. And we will see how different alternations in signs can affect this function as well. Now let's see how different signs can affect our graph. For instance, from the graph you can see the graph of e to the power of x. The y-intersection point is x equal to 0 and y is equal to 1. But we can change the signs from positive to negative and from negative to positive. And let's say we change the sign of x. As you can see, it will be reflected by y-axis. And we can do the same thing by changing the sign of e. And as you can see from this picture, it will be reflected by x-axis. Or we can put minus to e and x at the same time. Now at that moment, we will see that there will be 2 reflections, minus e to the power of minus x, and our graph will be reflected by x-axis firstly and will be reflected by y-axis secondly. And these are how different changes and alternations in signs can affect our graph.
One eternity later.
Now let's see the sign change. As you can see from the blue graph, the f of x is equal to ln x will be shown like that, but we can change the sign of x and it will be reflected by y-axis, and we can change the sign of ln as well, and as you can see from the red graph, it will be reflected by x-axis. And as we did in our previous part, we can change the signs of both of them, both of the components, and it will be reflected by y-axis and x-axis at the same time, and it will be shown by this blue line, as you can see. And please note that in every version of it, it will go through 1 0 point and it will never touch the y-axis. Now let's do some exercises and let's see concept questions. The first one is, the function f of x is equal to e to the power of x is called the natural exponential function. The number e is approximately equal to, as we said in the beginning, 2.72. And now let's see the question 3. It says, use a calculator to evaluate the function at the indicated values. Round your answers to 3 decimals. And in 3, our function is h of x is equal to e to the power of x. And the first indicated value is h1, which means we will need to replace x and 1, which will be equal to e. In the second part, it will be h of p, and it will be e to the power of p, and the third one will be -3. We will do like that, which means 1 over e cubed, and the last one is h square root of 2. We'll write it like that. Now let's continue with graphing exercises. Let's take a look at exercise 11. It says graph the function not by plotting points, but by starting from the graph of y is equal to e to the power of x in figure 1. State the domain, range, and asymptote. In 11, our function is e is equal to e to the power of negative x minus 1. And we need to start from y is equal to e to the power of x. Let's take a look to this graph. It will be when x gets 0, our y will be 1, and it will increase, so our graph will be like that. This point is 0, 1. Now the second one is y is equal to e to the power of negative x. In this part we plot the same thing, but as we said, when we change the sign of x, we will reflect it by the y-axis, so it will be reflected like that. So this point is still the same, it will be 0, 1, but it's reflected by y-axis. And the last part is y is equal to e to the power of negative x minus 1. As we said, when we have subtraction from the formula e to the power of x, we will go downwards by the unit that we subtract. So in this example, our graph will go downwards by 1 point, which means it will go through this point, starting like that and going like that, and this point is 0, 0, and our new asymptote will be this line, which is y is equal to -1. In this line, our asymptote was x-axis, which is y is equal to 0. But when we have subtraction, we decrease the value of y by 1, and our new asymptote is y is equal to -1, and our range will be the possible values of y, which means not included, starting from -1 to the upwards, which means to the positive infinity. Let's make it like that. And our domain is also asked. Our domain will be the possible values of x, and as you can see from the graph, we can have all kind of values for x, so we can show it as from negative infinity to the positive infinity, or we can also show it as this. So this is how to solve the graph. Let's do the hardest equation in this part, which is 16. Now let's see what is wanted. And as you can see, our function is g of x is equal to e to the power of x minus 1 minus 2. So we know some rules from the previous equation. For instance, if you subtract some number from e to the power of x, we will need to go downwards. If we would add it, we will need to go upwards, but in this case we need to subtract it. So let's start from the first one. Once again, g of x is equal to e to the power of x, which means our function will be like that, and this point will be 0, 1. This is the standard version of this function. And now we need to subtract 1 from x, which means g of x is equal to e to the power of x minus 1. Well, in previous parts we mentioned how to handle these subtractions and additions in terms of x. In this part, we will need to do the inverse logic. What is the inverse logic? What is meant there? If we have it, if we subtract 1 from x, we will go right instead of going left. If we add 1, we will be required to go left instead of going right. In this case, we subtracted, which means our first x was 0. Now our new x will be 1. And this is the point 1, 1. And our new function will be like that. And the last part is g of x is equal to e to the power of x minus 1 minus 2. Now again, we will do the same logic in the previous equation. Our point is 1, 1, and our y is 1. And when we subtract 2, we will be required to subtract 2 from y, which means our new y value will be negative 1, and our new x value will be 1. So this is the point, and our function will be like that. When it comes to finding the asymptote, we will do the logic there. Well, this is negative 1, 1. Our asymptote will be, let's say, this line. It will approach to this line, but it will never touch it. In previous equation, our asymptote was y is equal to 0, which is also x-axis. In this equation, since in the previous part our asymptote was 0, we will be required to subtract 2, which means our new asymptote will be e is equal to 0 minus 2, which will be negative 2. And when it comes to finding the range and the domain, the same technique here. Range is the possible values of y, and we will not include the negative 2, but we will write negative 2 because it will approach the asymptote, but it will never touch it. Once again, from negative 2 to the positive infinity, and domain is the possible values of x. And as you can see from this function, our possible values are from negative infinity to the positive infinity. So that's all. Thanks for watching. It was the video about natural exponential functions. I hope you enjoyed. See you later.